the lab directions that are on page 9. And what you should have seen is the balloon, when it was in the hot water, was getting bigger. And then when I put it in the cold water, it shrunk. And we got to talk a little bit about what happens at a particle level before you can finish page 11. But you should have page 10 at least started with some ideas in your science journal before you watch the rest of this one. So if you need to stop, be honest, stop it for a minute, try to do some page 10, and then get right back. Okay, so now that I have everybody who's at least attempted to do page 10, I have a picture here that shows some room temperature air particles, and they're kind of all scattered around. They're not really moving anywhere. If everything is the same temperature, there's no push to move anywhere. What happens at a warmer temperature, though, when we have more energy in our air particles, is they spread out. They spread out, they're spread farther, they move a lot faster, they push against the extremes. This is why tires blow out on cars when they get really hot, is because the air particles are pushing and pushing and pushing against the walls of the tire. So warm air particles push, 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 and they have high energy. Cold air particles, on the other hand, kind of sink and clump all together. They have low energy. They're not moving. They're not pushing against this container very hard. They have low energy. They're kind of in a clump. So when you have warm air rising and you have cold air particles sinking, so you see my warm air rising and the cold air sinking, we saw this in the container cloud model. So we have warm air molecules sinking. Here's another picture of warm air rising and cold air sinking. See how we have that cyclical motion again, where it's going around and around? Well, when you have that, wind happens. You have high energy, heated up air particles rising, and then they're taking up all this space, and they're pushing this cold air. The cold air has to sink, and it's spreading apart. It's not going to let vacuum, no air exist. That doesn't happen on Earth. So it cools off and it sinks, pushes into the warmer air which is rising, and this is wind. This is why we have wind. So the differences between the warm air and the cold air is what causes wind. Hopefully that will help you finish up page 10 if you didn't get it done. Make sure that you answer the questions on page 11, both 1 and 2. Okay? All right, see you in class.